this video, we will be discussing about question from Chemistry Topic 2, PRE-PSPM KMM 2023-2024. Questions 2a. A photon with the wavelength of 1094 nanometer is emitted when an electron falls from n equals to 6 to a lower energy level in hydrogen line spectrum. For questions I, determine the transition of the electron. So from the questions, it is given that the wavelength is equals to 1094 nanometer. Convert it to SI unit, you will get 1094 times 10 to the power of negative 9 meter. For these questions, we should use the formula 1 over wavelength equals to Rydberg constant times 1 over n1 square minus 1 over n2 square, where n1 is smaller than n2. Substitute the value given in the questions into the formula, and you will get n1 equals to 3. So the transition of electron is from n equals to 6 to n equals to 3. There are different values of RH and its usage. So if we want to calculate wavelength, we will use the first formula. If we want to calculate energy, we will use the second formula. For questions II, calculate the energy of the electron before it is excited. We will use the formula En equals to negative Rydberg constant times 1 over n squared. Substitute the value of n equals to 3 and Rydberg constant into the formula, and you will get the value negative 2.42 times 10 to the power of negative 19 joules. Please note that you must write the negative sign and also the unit joules. For question III, state the series of the respective line spectrum. Since n equals to 3, your answer will be Paschen series. For question B, the valence electron of element X occupies 3s, 3px, and 3pz orbitals. For question I, write the sets of 4 quantum numbers for the electron that occupies the highest energy orbital. The 4 quantum numbers here refer to n, l, m, s, where n is principal quantum number, l is azimuthal quantum number, m is magnetic quantum number, and s is the electron spin quantum number. So there is 3s and 3p orbital. So between these two orbitals, 3p has the highest energy compared to 3s. So there is 3px and 3pz orbitals. How do we determine how many valence electrons are there in the orbital? We will follow the Hund's rule. Hund's rule states that when the electrons are placed in a set of degenerate orbitals, each orbital is filled singly with the electrons of parallel spins before the electrons occupy the orbitals in pairs. Since there is 3px and 3pz, but there is no 3py orbital, we can determine that the electrons are only filled singly in 3px and 3pz orbital. That is why we only have 2 electrons in 3p orbital. N is the principal quantum number which indicates the energy level of the electron. Since the valence electron occupies 3s, 3px, and 3pz orbital, we know that the value of n equals to 3. So for L is the azimuthal quantum number, which is the shape of the orbital. The highest energy orbital is p, so the azimuthal quantum number for p is L equals to 1. So M is the magnetic quantum number. Magnetic quantum number indicates the orientation of the orbital. From the questions, we know that there is two orientation for p orbital, which is 3px and 3pz orbital. So we can use the value of negative L to positive L for value of m, which is -1, 0, and +1. We can choose either two from the three values. I have chosen -1 and 0 for this question. So S is the electron spin quantum number. Electron spin quantum number can be +1/2 or -1/2. According to Pauli exclusion principle, we know that no two electrons from the same atom have the same four quantum numbers. So we must make sure that the value of nLMS for each electron is different. So please take note, you must write n equals to 3, L equals to 1, m equals to -1, and s equals to +1/2. You cannot skip out on writing nLMS as it will cost you your marks. So second thing, you must make sure you write the negative and positive sign for the magnetic quantum number m and electron spin quantum number s. If it's +1/2, you must make sure that you do not just write 1/2. For question II, draw the shape of the highest energy orbital x. The highest energy orbital is 3px and 3pz orbital. So you must make sure that you draw your three axes and label them correctly. You draw the dumbbell shape of the p orbital correctly and the orientation of the dumbbell correctly, as well as label your diagram 3px and 3pz orbital. Please take note, you must change the position of the orbital. It is unacceptable for you to change the axis of the orbital. So at the corner of this video, I have given you an example. In this example, I changed the position of Z and X axis. So you must never do this in your exam. For question III, state the total number of electrons which occupy L equals to 1 in element X. According to Aufbau principle, we know that the electrons fill the lowest energy orbital first and other orbitals in order of ascending energy. Since the highest energy orbital is 3p, that means that the 2p orbital is also filled completely with electrons. Since the p orbital can hold 6 electrons, that means the total electrons when we add up 2p orbital and 3p orbital is 8. That is 6 from 2p orbital and 2 from 3p orbital.